Hi there, this is N8.2, all about percent. So percent is probably one of the most useful things that you'll ever learn in math because we use it all the time. This particular outcome is dealing with fractional and decimal percents. That just means something like 4.5%. That's a fractional one, or we could say it as a decimal, 4.5%. So in previous outcomes, you've just done whole numbers. Now we're including fractions and decimals, so no big deal, same procedures. Percent still means out of 100. So if you're given a number like 4.5% or 4.5%, it doesn't matter that there's a decimal. You take that percent and show it out of 100. Converting a percent question into a mathematical expression, so you need to know that is means equals. Of, you're probably going to multiply. Percent means out of 100. When we convert it into mathematical expression, though, we usually use the decimal form for our percent. So it does mean out of 100, but as a decimal is better. And your variable, that's the part when they say what is blah blah blah, we're going to put in the x. Using percent in real life situations, and I have a couple of examples coming up, but it could be anything from your math exam to the food label on the back of your Cheerios. So there's percents all around us. Showing percent that contains a fraction, so we just talked about that, and being able to maybe draw that on a 100 chart. So you would have 7 rows filled in, right? You would have 4 tenths filled in, and then you would have a half a one filled in to show 74.5%. I know that percents larger than 100 means it's greater than one whole. And so if you have a number like 345%, well, that just means 345% means out of 100. If you actually type that into your calculator, you would get 3.45. And so anytime they've given you a percent that's bigger than 100, that means greater than 1. So the media uses this kind of strategy all the time because 345% sounds huge, right? Really all they mean is it's tripled. It's 3.45. But it sounds fancier to say it in percent, so you'll see that all the time. Converting fractions to percent. So if you got 4 out of 7 on your quiz, you can type that into your calculator, which I have right here. 4 divided 7 means you got 57% on your quiz because my calculator says 0.57. Okay, so as a decimal, 0.57. Okay, it means your mom's probably going to give you spanking when you get home, but you're able to calculate the percent of what you got on your quiz. Drawing pictures to show fractions, which we sort of did up there with the 340 or with the 74.5%, and knowing that they're all related. Fractions, decimals, and percents are just all ways to show part of a whole. In the case of 345%, we have a mixed fraction. We have 3 wholes plus part of a whole. So, solving problems with percent. Tax is a really common use of percent, and you'll always have to add the tax. And then discount, you would always have to subtract your discount. And I'll show you some misconceptions that will come up with that one. Using order of operations with percent. Of course, BEDMAS is going to be in every question you ever do from now on, so get comfy with it. Analyzing examples of percent given in the media. Recognize when it is used to deceive people. So like we said with that 345%, it's pretty common to see that in the media. And knowing why percent is used in real life. So comparing 2 items. If you got 57% on your quiz and I got 58%, we're both getting a spanking when we get home, but it is a way to compare 2 items. To show how a topic breaks down into parts, like a circle graph, perhaps. So maybe this part of the audience answered this way, 50% of them said this, and 15% said that, and a circle graph always has to add up to 100. So if we've got 65% showing here, then we need the rest to make up the 100, so 35% would be in that spot. To show patterns, you might say that, well, on Tuesdays, we're missing 10% of our students, but on Fridays, we're missing 50%. Okay, and so you could maybe analyze your patterns that way. And calculating changes in amounts, so we might say 5 years ago 70% of students owned a cell phone. This year 90% own a cell phone. So just calculating some changes over the years. Percent is really handy because maybe when we took this calculation we surveyed 40 students, and then this time we surveyed 100 students. So you can say that 90 out of 100 versus whatever out of 40 that gave us 70%. So you don't have to have the same numbers to calculate a percent. You can still come up with a good comparison. It's pretty handy. All right. Here are some examples of some decimals, and we're going to convert them to fractions and to percents. So 0.78. 7 is in the 10th spot, so technically that means 7/10. The 8 is in the 100 spot, so technically that means 8/100. So do a little fancy math here with our 7/10. If I multiply the top by 0 and the bottom by 0, because what you do to the bottom you must do to the top, I end up with 70/100, right? And I have 8/100. So because those two have matching denominators, I can add them together and say, well, that's 78/100. And technically that is how we read a decimal. We use the last guy, the 8, and what his place value is, he's hundredths, so we can just say 78/100, there, hundredths. Okay, so if you typed 78 divide by 100 into your calculator, it would show you that decimal. And we know that percent means over 100. So if I'm looking at this fraction up here, 78/100, well, anything over 100 can be expressed as a percent, and any percent can be expressed as a number out of 100. So they go back and forth like that. So here we have our percent, here we have a fraction, and here we have the decimal. We've got all three chunks. Your fraction you might be able to reduce a little bit because 78 is an even number, and so you could divide by 2 and divide your 100 by 2 and have something out of 50 if you really wanted to. Okay, let's look at our 1.78. So we know that this is a whole number, and here is our fractiony part. So we know that it's 1 and 78/100, or 178/100, or 178%. Okay, so there's an example of where we're not just dealing with a decimal, we have the whole number as well, so that's where we get that 100/100% from. This next example, not only do we have a number in the ones column, we have a number in the tens column. And so same thing, percent just means these two place values. So we have 41 and 78/100, or we have 4,178/100. We could express it that way. Because remember when I said we name decimals by the last dude. So if he's hundredths, then this whole number can be expressed as hundredths. And then we can write it as hundredths. And that just means 4,178%, because anything over 100 can be expressed as a percent. So here we have our fraction, another fraction that could be reduced. We have our percent, going back to our original decimal. So they're all nice and related. Here's an example of how you turn an English sentence, what is 30% of 54, into a math equation. Okay, so anytime you have a percent problem, you really have to think, what are they asking me? Do they want to know what a certain percent of a number is, or are they telling me that they have a certain percent? And so you need to figure out what exactly they're asking you. So for example, if you had a question that had maybe a jacket for $54 and then there was a sign beside it that said 30% off, you have to really think. They are asking me to find out what is 30% of that jacket, and then I'm going to have to subtract that discount at the end. So first thing you want to do is write out your English sentence. What is 30% of 54? And then convert each word into a math thing. So the what becomes our variable. Doesn't matter what variable you use, but we used x in this example. Is means equals. 30% as a number, you could put 30 over 100, and in some cases it's best to use the fraction, but most of the time you're going to use the decimal, 0.3. Of means multiply. They've used a dot here. I probably wouldn't recommend that. I would say use brackets. So 0.3 times 54, which gives them 16.2. So that is the discount. So then you'll have to think the jacket price, subtract the discount. Let's just dig out a calculator here. 54, take away 16.2, $37.80. So that is your price. Okay, another example here. What number is 5% of 20? So what number? That's our variable. So we're done with this stuff. Is means equals. 5% as a number is 0.05. Don't get confused and put 0.5 because that's 50%. Remember, percent is being divided by 100, and so the decimal place has to move 1, 2 times. 1, 2, right? Of means multiply, and there's our number. 0.05 times 220. 11. Okay, on to the next one. 35% of what number is 14? So this one's worded a little bit differently. They've given you the percentage, but they don't know what number the percent is of. Okay, so let's just do one word at a time. How do I write 35% as a number? Well, 0.35. What does of mean? It means get your brackets out because you're going to multiply. How do I write what number? Well, that's your variable. Is means equals, and 14 is already a number, so 14. So 0.35x equals 14. So what do we do to get our variable naked and alone? Just going to change color here. Right now the x is being multiplied by 0.35. Don't you wish you had a 0.35 on the bottom so that you could just cross those out and they would be gone and your x would be all by itself? So if you're going to do that to this side, you need to do it to the other side of the equation as well. I have drawn a fraction bar and put a 0.35. So I'm going to draw a fraction bar and put 0.35, because if I'm dividing on one side, I need to divide on the other side. And then you can just simply calculator that. 14 divide, fraction bar means divide, 0.35 is 40. Okay, you always want to keep your equal signs lined up. The stuff that's on this side stays on that side. So if it's just the x that's left, that x gets translated down and we just redraw it. And once you figure out what this is, that stays on this side. So everything is organized. An item costs $15. The sales tax is 6%. What is the cost of the item after taxes? So taxes, it doesn't say in here, but obviously we're adding. When it was a discount, that jacket that was 30% off, you're going to subtract the discount. But if it's taxes, that means you're adding. So it doesn't really say that in this question, so I'm hoping we're all smart enough to know that taxes are something that you have to pay in addition to what you're paying for the item. So technically they are asking you, what is 6% of 15, right? So to convert that into math, the what means x, is means equals 6% as a number is not 0.6, it is 0.06, of means multiply, and there's the 15. So calculator that, 0.06 times 15 is 0.9. So we keep our x on this side, our equal sign lined up, and 0.9. And so in this instance, we have to add, remember this is just the tax that we're paying, an extra 90 cents. So this is 0.9 of a dollar because we were using dollars up in our example. So what we ended up with was 0.9 of a dollar. So the total price is $15.90. Oh yes, brace yourselves. Here comes the sex ed slide. Okay, here we have a lovely chart about birth control methods. Now, just as my personal disclaimer here, this is birth control methods, not disease prevention. So this isn't talking about preventing or controlling any kind of STD or AIDS or anything like that. This is strictly pregnancy. So here we go. Here's a little lesson. You'll often see charts like this, and it's fairly important for you to understand what they're telling you because there's a lot of information on this chart. And if you don't know how to read the percentages, you can make some uninformed decisions that might seriously affect your life. So this is why we're talking about this one today. This one is measuring effectiveness of birth control. So the rates that they have shown here, that means that it's effective birth control, meaning you will not get pregnant. Okay? And so what they've actually given here is the opposite though, because they've given the you will get pregnant 24% of the time. You will get pregnant 28% of the time. So if you're using just the calendar and trying to plan your activities around dates that coexist with your cycle, you're probably going to be okay 75% of the time. Okay, but 24% or 76, I guess technically, rounded it off there. Okay, 76% of the time you're good to go, you are safe, and 24% of the time you will have a baby. There he is. Okay, so moving up the chart, they talk about condoms that are 18% risky. So 18 or more pregnancies per 100 women. And anytime you see per 100, that's percent, right, out of 100. So 18 out of 100 or 18% of the time, the condom is ineffective and it will result in a pregnancy. Let's move on up to something a little more common here. The pill. 9% of the time, you're going to have a baby. Okay, and 91% of the time, you are okay. Moving up to the most effective birth control method, looks like maybe the IUD. Now these are surgical options, and sometimes they are permanent. So we're not advocating that anyone use these, but just so that you know what the chart means. They're saying 0.2 to 0.8, so that's less than 1%. Okay, so I'm going to make the thing that looks like an L, which is less than 1% of the time you will get pregnant, and 99% of the time you are good to go. However, it's 99%, it's not 100%. And so, yes, it's the most effective, but it is not 100% effective. Okay, so the only 100% effective way is abstain, which means do not have sex. So there is your sex ed /% lesson.